So 2/9 is percents.
Oh, this is the fun stuff. Yeah.
Oh, these are really fun.
And first thing is the percent. Kind of how this ties into what we've been doing the last couple days is the percents are really just a ratio. That you could look at a ratio as like one number to another number. We said like if you have like 3 guys and 7 girls, the guy-girl ratio would be 3 to 7 or 3/7. A percent is really going to be that same sort of thing. It's how much you have over 100, the part divided by the whole. So I'm going to say it's a ratio that compares a number to 100. So a ratio, if you look at that as a fraction, that compares a number to 100. So 43% is saying that you have 43 out of 100, something like that. I'm going to go through and kind of do the problems 2 ways. The way that the book teaches it, but then I want to go back and do them kind of a way that I think you'll probably find is faster. But the first thing, so Roman numeral 1, I'm going to say is method 1. So method number 1. And that's to make a proportion. So make a proportion. And I'm going to try to stay on the left-hand side of my notes so I can go back and do the right side. You might want to kind of try to do the same for you. So method number 1, make a proportion. So for my example, I'm going to go more than halfway across the page, but I want to do it twice, once kind of on the left, once on the right. And by that, make a proportion, kind of what we're looking at is this thing here. I'll put it in red for dramatic emphasis. Is they say that if you have the partial amount divided by the whole, that's going to equal the percent divided by 100. So for a proportion was 2 ratios that are equal or 1 fraction that equals another fraction. So we could set it up this way. The other way is just going to be like 1 step shorter. There's nothing wrong with this way. Just it'll take you 1 step longer as you do the problems. So my first example, I'm going to say if 13/27, if 13 out of 27 of the class are girls, so of
Not true.
I made this up, of the class
Oh, yeah.
are female, what percent are girls? And this one is already kind of partway done for you, because at 13/27, the 13 would be the part of the class that are girls, the 27 would be the whole. So as I take this proportion thing here, the left side's kind of already done in that 13/27. Then we could say this equals that other fraction, equals the percent over the 100. And you could either leave that as a percent. I personally like kind of making that into a variable. I like seeing an x in there, but you could kind of do it either way. And now you could say, well, 27 times what gives you 100? That doesn't work out nicely. So in my mind, the easiest way to get that is to probably cross multiply and divide. So I'm going to do 27 times x, so I get 27x equals 13 times 100, so which is 1,300. And now to get that by itself, I would take and divide both sides by the 27. So we come up with x then, it's 48.1%. So 48.1% of the class is girls. I want to jump and do a different example, but what you're going to see in my examples is we're going to have the unknown be in several different places. So for this last one, our unknown was right here, it was the percent. Then you'll get another example where the unknown is going to be that partial amount. Then we'll have the final example where the unknown is this whole. So it's kind of like 3 different types of problems that you could have. Going to quick do an example of each, then we'll go back and I'll try to show you the way that I think is better. Way that'll help you more when you start hitting like Algebra 2 and stuff. I'm going to say if 40% of the class buy the teacher donuts, so if 40% buy donuts, the rest of the problem should be how heavy would I be? Okay, 40% of the class buy donuts. How many students in a class of 20? So how many in class of 20 buy donuts? And if you go back and do it this proportion way, part divided by the whole equals the percent over 100. Well, then we take the 40%, we put that in for the percent, right? I'm just going to try to quick whip through it myself. So 40 goes here over 100. And now we just need to figure out the 20, is that the part or the whole? the whole. It comes right after that word of. Whenever you have that word of, typically right after it's going to be the whole that you'll see. I'm going to write it in here that you have of. The next thing is going to be the whole. That's worth writing down if you're ever not sure of that. But an is in there would be an equals if you see it is in it, but of something is going to be of the whole. So I could say I have 20 down here. I have an x. You could cross multiply and divide 100x equals 800, and then divide by 100. Or you could say 20 times what gets me up to 100? So 20 times 5 gets me 100. What times 5 gets me 40? So cross multiply and divide or do something like that, but x is going to be 8. 8 people would buy me donuts. So. Sandy's. Okay. All right, we good on that one? Then the last one is going to be when the unknown is in that part place. So I'm going to say last example. 16% of the class have been to Silver Lake, so 16% of the class to Silver Lake. If 4 people have been there, how large is the class? So if 4 have been there, how large is the class? So we have the part divided by the whole equals the percent over 100. So we have 16%, that's easy to stick in there, so 16 over 100 equals, now 4 have been there, so is 4 the part or is 4 the whole? 4, yep, 4 is the part of the class that had been there. And we're saying how large is the class? What's the whole number of people? And then for this you could go through and solve it like I did the last one. 4 times what gets me 16? Yep, so 4 times 4 is 16, or you could say 16 divided by what gives me 4. But then you do that same thing, okay, what times 4 gets me 100? Yep, so x has to be 25. Or you could go through and cross multiply and divide 16 times x equals 4 times 100 and divide that way. So that's one way to do it. That's the way the book teaches it. Here's the way I like more. I'm going to do a Roman numeral 2 down here and then we'll go back up just quick to those examples. So method number 2. You could put it here, or you could, if you wanted to, write it in that right half up above. Actually, I think I'm going to do that instead. Let me try to erase this a second. If you wrote it down the bottom, there's nothing wrong with that. I'm just kind of like looking at what my notes did. But I think with this program, I can squeeze it right here. So Roman numeral 2, method 2. And I'm going to call this manually convert percent. I need to slide this over a little for myself. So manually convert the percent.
Multiply?
Yep, so of means multiply. And if you have that word is means equals. So that'll help you seeing that. And we're going to have to squeeze in here somewhere, changing a percent to a decimal. So I'll maybe do kind of like a squiggly line. And if you have a percent to a decimal, you move the decimal point 2 jumps, right? So if I wanted to do 50%, 50% is going to be the same as 0.5. If I have 15%, that's the same as 0.15. You still with me? Other people too? If we have 4.5%, that's going to be 0.045. And if I lost it, in all those what we're doing is saying, okay, 50%, the decimal point would be right there. We move it 2 jumps to the left to get the 0.5. 15%, the decimal point's right there. You move it 2 jumps to the left, you get this 0.15. For 0.5, you still have to go 2 to the left, but that puts me out 1 further in the front, so that's why we need to put the 0 in there to hold the place. 4.5% is 1 jump, 2 jumps, 0.045. Does that make sense? What we're really just doing there is we're doing this right-hand side of our proportion. That when you take that percent, the 50% divided by 100, it gives you 0.5. If you put a 15 in here, 15% divided by 100 gives you 0.15. So we're kind of manually doing that right side of the equation. Last thing to squeeze in the notes before we try to do some of these examples is this here. So the equation that I would recommend using would be this. So see if you can squeeze it in. I'm going to say it's the percent times the whole. So percent times the whole equals the part. Okay, so this looks familiar to last year? I like this a lot more, and I think people are more likely to actually do it this way because it's less work. But percent times the whole equals the part. So if we were to go back and try to do these same examples using that new information, so we have 13 over 27 of the class are female, what percent are girls? Percent times the whole equals the part. And one thing is it's telling us in the question this year, what percent are girls? So we know the percentages are unknown. I'm just going to put an X there. So you have to figure out 13 and 27, which one is the part, which one's the whole. So if 13 out of 27 of the class are female, the 13 has to be the part. That's the number that are girls. 27 would be the whole amount. To get X by itself, we'd have to do what to both sides? Divide by 27. And you'll notice we're really doing the same math operations as what we did on the other side, are real similar. That we're doing 13 divided by 27 here. Here we did 1,300, 1,300 divided by 27. So our answer is going to end up being X is 0.481. Well, 0.481 is going to be what percent? 48.1. Yep. That it's the opposite of what we were doing up above, that we have the decimal, we want to write it as a percent. It's 48.1%. Is that clear to everybody? Then the second one, if 40% of the class buy donuts, how many in a class of 20 buy donuts? Percent times the whole equals the part. So now we have 40%. Now we need to, in the percent, we need to put that in as 0.4. Or some people like seeing it 0.40 till they get a little bit more used to it, but 40% is 0.4. Of 20, the 20 then has to be the whole, because, or you could say the of, like we said above, means multiplication. So 0.4 times 20, if we punch that into our calculator in one step, it tells us the answer is 8. That 8 people buy your teacher donuts. I probably should go back up and make the 2 little comments that came out in this one. That in this equation thing here, my percent, this here has to be as a decimal. So percent as a decimal. So in that last example, we had 40% of the class, so we had to change that to the 0.4. And this multiplication thing, if you wanted to, you could put right there the word of. You know, that of is kind of signifying that that next thing is going to be the whole. So that might help make your notes a little more clear if you're looking at this later. All right, final thing. Final example. If 60% of the class has been to Silver Lake, if 4 people have been there, how large is the class? So we could do percent times the whole equals the part. 16%, we put that in as 0.16. So you have to change it to a decimal first. Now we have times the whole equals the part. So if 4 have been there, is that the whole or the part? Part. That's the part. So you could say 4 is the part. So my unknown is the whole. So now to get X by itself, I divide by 0.16. And then that tells me X then, if I punch that in my calculator, I get 25. I'm okay with you doing either one of those ways. Setting up a proportion like we did for the examples the first 3 times, or doing it the second way. The second way is going to help you a little bit more maybe down the road as you start doing percent increase, percent decrease, but either one, you can do it either way really all the way through.